Hello students, once again. In the last class we studied about the phase control converters. In the phase control converters we have studied how the converters are controlled and different types of control techniques. At the same time we studied about the half phase single control rectifier using a single thyristors with using a R load. So as we studied in the previous class, such that when the R load is connected to the thyristor, when to the rectifier, whatever the input may be present on the output it is present on the output, and there is no voltage drop. There is a less voltage drop across the rectifier output. Similarly, we are going to study here the same half wave controlled rectifier with using the resistive as well as inductance load. What we are going to study in this class. And the session outcomes are such that you are able to know it. You can differentiate so what is the difference between the R and RL load. When I connect the load, there is inductance resistance as L load. So what happens to the corresponding output across the thyristor output or rectifier output. At the same time, once again I want to repeat this, the rectifier is a circuit which converts the AC to DC, and here I am going to use half controlled rectifier. Instead of diode, I am going to use this here. The diagram of this as shown in this diagram. You can see here I am going to use the inductive load. The inductive load is a combination of resistor as well as the inductor. As you can see here, it's a inductor is connected in series with our thyristor here. As we can see here, as we previously said, this as that. So the input voltage is the AC signal. It is which is having the voltage level of 230 volts and the frequency of 50 hertz. And when it's the step down at the secondary of the transformer, where our input voltage is nothing but a Vm sin omega t, which is applied to this thyristor. So during positive off cycle of the input, the thyristor is forward biased still, but it will not conduct. You can see here. When I apply the positive off cycle, to this diode, so what happens is such that the diode will be forward biased, but it will not conduct. So such that the output voltage across the load resistance is zero. Very, very important. The output across voltage across is zero, because the thyristor is not conducting, is a short circuited. So still it acts as an open circuit. There is such way there is no output voltage flows from the secondary to the load inductance load here. So to conduct a thyristor, so what we do is we apply a short trigger pulses to a thyristor. By doing this, what we do is we'll make the thyristor to start to conduct at the instant when I apply the short trigger pulses at the gate trigger. So when I apply this trigger pulses to this thyristor, what happens? The correspondingly simultaneously the thyristor starts to conduct and the circuit becomes short circuit. So whatever the input voltage is supplied to the load inductance load as well as the load resistance, you can see here. So whatever the input voltage at the same time, the same voltage is supplied to the load resistance. At the same time, you can check here. So when I apply this input voltage across the inductance, what happens is the inductor is having the capacity to load the charge. So what it does, it stores the charge and it becomes this circuit becomes positive and this becomes negative, and it starts to store the positive energy. What are the input voltage is supplied? This is the corresponding is flowed to the resistance as well as the output. We get the input voltage. So when the input voltage goes to the negative off cycle, when the input voltage goes to the zero voltage, correspondingly what happens is that the thyristor stops conducting. The thyristor stops conducting when the input voltage goes to zero. When the corresponding current at that point is zero, then what happens is the thyristor stops to conduct and it acts as a open circuits. So there is the voltage flows through the circuit. But what happens in this output waveform is such that you can see here the load inductance, what we are connected here is it stores the charge. Okay, it stores the charge. So such that what happens is during the negative off cycle of the input, so what happens is our inductance starts to discharge. It starts to discharge. You can see here in the pi our input voltage is 0 as well as the output voltage also 0, but still during negative off cycle of the input, the thyristor is open circuited, open circuited, so there is no voltage flows from the input voltage to the output voltage. But still what happens here, our inductance what it does is it stores the energy, and during the negative cycle of the input energy it starts to discharge through the resistance. So it starts to discharge through the resistance, and the polarity becomes changed, as well as therefore the small negative voltage goes through in this negative half cycle. That what we can say, the stored voltage is discharged through the resistance. That is the voltage what we are going to see here in this diagram. So at the same time, what happens with the current also, you can see here the current also goes to the maximum. So whatever the current is flowed to the little bit. But what happens here in this, the little bit of the voltage is added to the circuit such that the input voltage will be maximum, or that what happens is at this point the maximum will be voltage here. So until unless if I don't apply the pulse voltage, the alpha, the firing angle alpha, if I don't apply trigger pulse at that angle alpha, so the thyristor will not conduct. To conduct a thyristor, I apply the gate pulse, short term trigger pulse at an angle of alpha. When I apply this supply voltage alpha, similarly simultaneously what happens is the thyristor starts to conduct, and whatever the input voltage will be applied to the corresponding load voltage. But what happens here in this, the inductance will start to store the energy. In this way, the inductance load to the thyristor will work in this thyristor circuit. Similarly, if I want to find out the voltage across this circuit, once again we know this average voltage of this V0 is given by VL, and the time duration is 1/2 pi, and you can see here its differentiation is 0 to 2 pi, and V0 d of omega t, V0 is nothing but Vm sin omega t, its input voltage. At the same time, you can see here the limitations of period is the input voltage varies from 0 to alpha, and alpha to beta, and beta to 2 pi. Okay, when I show you here, so 0 to alpha, one timing 0 to the firing alpha, and alpha to another one is the beta. From this beta to 2 pi is the duration in which our thyristor works here. 0 to alpha and alpha to beta, and beta to 2 pi is the in this time duration thyristor works. That's why we are taking this equation as you can see here, 0 to alpha and alpha to beta, and beta to 2 pi is the V0 output voltage here. So when V0 is 0, for omega t is equal to 0 to alpha. When 0 to alpha is there, the thyristor will not conduct, therefore there is no voltage flows in this circuit. That's why this term becomes 0. So when alpha to beta is applied, the thyristor starts to conduct, and V0 to d omega t is the when we have this output voltage. When beta to 2 pi is also 0. So at this point these two become 0, then we have only equation. What we have in the equation is alpha to beta into V0 d omega t. So at the same time, when I apply this equation in this, V0 of AV DC is 1/2 pi, the alpha to beta V0 to d omega t, where V0 is equal to Vm sin omega t. What is the input voltage equation? And it works in the range of alpha to beta. So when I apply this equation in this here, so Vm is taken outside, and the equation becomes Vm by 2 pi. And when I integrated with the sin omega t with d omega t, then this equation becomes minus cos omega t in the ranges of alpha to beta. So when I apply this, the upper limit as well lower limit, what happens, this equation becomes minus of cos beta plus cos alpha. Then in the equation I can write this cos alpha minus cos beta. And similarly, I can write this equation of V average of d is Vm by 2 pi into cos minus of alpha minus cos beta. This is the equation what I am going to get this in this equation. Okay, this is what the average load equation for when I connect the load inductance as a load resistor. Next, we are going to study single phase half-wave control rectifier with inductive load with an effective of freewheeling diode. When I connect the freewheeling diode, what happens to the working of the thyristor when it is connected in series with when it is connected parallel with the inductive load. So what is the working of freewheeling diode when I connect this in series with this thyristor? So what will happen to this, and what is the output voltage we are going to get, and we are going to study here in this side. So okay, once again I'll repeat. So when I apply this input voltage is 230 volts, 50 hertz supply, and it's stepped down here, and the equation is given by Em sin omega t. during the positive half cycle of the thyristor will not conduct, because it is forward biased. There will be no voltage across this circuit. So there is no voltage flows through this thyristor until unless a trigger pulse or a trigger voltage or a trigger current is different computation techniques such that I can trigger this thyristor on. So when I apply this short trigger pulse to this trigger gate, simultaneously at an angle alpha, when I apply the short trigger pulses to the gate, the thyristor simultaneously starts to conduct. And it has a short circuit. So whatever the voltage supplied from the primary to secondary, same voltage will flow through this thyristor, and it is flows through the resistance as well as inductance. So this diode becomes reverse bias during the positive half cycle. It is reverse bias. So whatever may be the voltage is applied at the secondary of the primary, secondary of the transformer, it is fed to the direct resistance load as well as the inductance load. When the supplied input outlet is supplied, the inductance load, what it does, starts to store the charges. It starts to store the charges, and the circuit is in this way. What happens during the negative half cycle of the circuit? What happens is, that thyristor is, what happens is, thyristor during the negative half cycle of the thyristor acts as the open circuit. It will reverse biased. At the same time current is equal to 0, such that the thyristor acts as open circuit. There is no voltage flows through in this thyristor. At the same time, what happens in this, that when the inductance at the positive half cycle is inductance, the inductance has stored the charge up to the EM, what is the supplied input voltage is given to this inductance. So during negative half cycle circuit, the thyristor acts as open circuit. What it does is the inductance start to discharge through this freewheeling diode, so such that no voltage is once again supplied back to this is EM sin omega t. So in this voltage, the load, the inductance start to discharge through the freewheeling diode. Simultaneously, the same voltage goes through the resistance, and the same small voltage goes through this circuit. So I want to show in this diagram, you can understand this. This is the positive half cycle input voltage. So during the positive half cycle input circuit, the thyristor is forward biased. You can see here the thyristor is forward biased, but there is no voltage flowing through our thyristor. You can see here our voltage is 0. So when I apply a gate pulse, short trigger pulse at an angle of alpha, so when I apply short trigger pulse at an angle alpha, what happens is the thyristor starts to conduct at the point when the input voltage is. So you can see here, whatever the input is applied, same voltage is supplied to the load resistance. This is what happens during the positive half cycle of the input. What happens during negative half cycle of the input? What happens is here such that the thyristor becomes open circuit, so there is no current flows through our circuit. There is no current flows through our thyristor, and there is no voltage supplied across this thyristor. So at the same time, what happens is, at this point, you can see here at the time t here, whatever the voltage stored by the inductance, whatever the energy stored by the inductance when it is forward, when the thyristor is forward, that voltage is stored in this inductance. That induction will start to discharge. Okay, when the time becomes 2 pi, automatically it becomes the minimum point of the value. At that time, it becomes a discharge. So when my input voltage is 0, you can see here the current is the minimum. When the thyristor starts to conduct, the thyristor current goes to the maximum value. At the same time, the stored voltage and the thyristor and the inductance stores the point here. When the pi is, when it is 0 and the angle is pi, there is a maximum. The value of the load voltage is available at the resistor inductance load. So during negative half cycle diode, the thyristor will not conduct, there is no output voltage, but still what happens is that the inductance will be storing some charges that will discharge us through the resistance through using the freewheeling diode, such that the no voltage will be fed back to the supply. That's what the advantage of freewheeling diode, and the cycle is repeated similarly in this diagram you can see here. Okay, once again I am to repeat, in the positive half cycle of the STR starts to conduct at a firing of angle of alpha. So when I apply the firing angle alpha, the thyristor starts to conduct. There is a drop across SCR. A small negative output voltage is equal to supply voltage will be flowing through this. Due to RL load, the current through SCR increases slowly. At an angle of pi, the supply voltage is at 0, where the load current is the maximum value. You can see here there is a current is the maximum value. It's a maximum value is at the load current. Similarly, in the positive half cycle of the inductor, you can see here the inductor stores charge and that generates a voltage. You can see here inductor stores a charge that generates a voltage. You can see here this voltage is here. At the same time, in the negative half cycle, the voltage drop across inductor is forward biases the SCR and maintains the conduction. As well as at a pi angle, voltage 0, the load current is maximum value. In the positive half cycle, inductor stores energy and generates the voltage. In negative half cycle, voltage drop across inductor forward biases the SCR, maintains its conduction. And it is clear that freewheeling diode helps in the improvement of power factor of the system. So whatever the power is supplied to this, it maintains the current as well as the corresponding output is the power factor such that the output devices can be driven. That's what the advantage of freewheeling diode. At the same time, okay, the freewheeling diode is connected in circuit across RL loads in such a way that provide an alternative path for decaying load current, so that the thyristor current is allowed to become 0 and the thyristor is allowed to turn off. That is what the advantage of freewheeling diode when I am using this freewheeling diode. Okay, thank you one and all.